Yes, yes.
Give him a couple weeks to quiet down, I guess.
Sir, I'd be honored if you could join us and stay.
No, I'm not going to stay because I can't end this conversation, but I did want to show up and say I appreciate y'all's effort in pulling this together and everybody's committing time to come and share experiences. But I so I'm not leading the conversation or anything, but I just wanted to stick my hand and say thanks. So thanks.
Well, thank you for coming by.
Go ahead and don't let me. I'm going to bail out so y'all make my head hurt.
Final iteration.
You like that?
I do.
That was Ken's idea.
Sold the rights to Hollywood yet? Sounds like a
Not yet.
action adventure flick.
As most of you probably know, today is my last day. I'll actually be leaving from here on my way to Tennessee. So,
After lunch.
After lunch, yes, after lunch. But Rob asked me if I had any things to say, and I thought about it, and I decided that I would like to come and try to explain, basically the method behind my madness in a lot of the presentations that I've done in Devloop over the course of it. So, where I'd like to begin is let's talk about what we're going to do. First, I want to talk about what our goal is. As software developers here at Tyson, what I believe our goal should be. Then, what are the obstacles that we deal with on a daily basis? What do we keep running up against? And how can we overcome these obstacles? And really, that's where what I've been talking about in the past comes in. I believe that's how we can overcome these obstacles. And then finally, I'll just wrap it all up with some questions. So let's start out with what is our goal? Well, I believe our goal should be to quickly deliver error-free software that accommodates our customers' needs now and into the future. But that is really challenging. Now, I put in here, tried to put a little humor in this and said, reality check here. What is really my goal? Because, that first goal is kind of fluffy. So my goal is to really make my job as painless and as enjoyable as possible. What's neat about that, though, is I believe that coincides with meeting our customers' needs. I think we can do both, okay? It's not one or the other. So this is where it really gets challenging for me because there's so many things that stand in our way of achieving our goal. And they're so interrelated. The thing that seems to come to mind the most is complexity. Because we're always dealing with complexity no matter what in software development. It's just inherent to software development. And we have to manage this complexity all the time for us to effectively meet our customers' goals. Along those lines, excuse me while I grab my notes here, make sure I'm not forgetting anything. Along those lines is we have discovery. Discovery is a part of the process. Anytime we go to develop software, there is a discovery process. And I think too often we may ignore this discovery process. It's a discovery process for both ourselves and for our customers. And it's often only through finding the solution are we able to truly understand the problem. And that's the reason that I think things like iterative development are so important, because they allow us to attempt a solution, learn from it, then go back in a second iteration and refine that solution. There's what I often call rough draft coding. I think too often the mentality is that, hey, I got to get this to work, so as soon as it works, boom, we're going to slam it in production. Well, I can almost guarantee you that our first solution is not going to be our best solution. So therefore, I think we should always try to go back and take what we've learned from our initial iteration and apply it. Also, change is another obstacle that we deal with. Change is prompted not only by the changing market, business, but also by legislation, litigation, and discovery. Discovery is a key element that causes our software to change. So I think with change, we know it's going to happen. And there's two ways we can choose to deal with change. One is we can try to ignore it and basically take a snapshot of the requirements at the very beginning of a solution and then code to that and ignore everything else. Ignore what we learned in the process, ignore any changes that may occur over the life or the development cycle of this particular piece of software. The other is we can choose to accommodate change. And in my opinion, accommodating change is really where it's at, because that's what's going to make us most valuable to our customers. It's what's going to allow us to meet their needs. And I believe it's also going to be one of the things that makes my job less painful and easier. Because if I write my software, if I want to embrace change because I know it's going to happen, then I'm not going to get frustrated when it does. If I design my software in a way that I can accommodate change, then I'm not going to get as frustrated when it changes. However, anytime to accommodate change, your software must be more flexible. And anytime you add flexibility, you add complexity. So now then, we've just increased our first problem by accommodating change. So now we need means to manage this complexity. Another thing that I think is very important and something that we struggle with a lot is communication. And this communication is not limited to between the developer and the customer, the analyst and the customer, the analyst and the developer. I mean, it's communication as a whole. As all of you probably know, documentation that you write for your software, if not maintained diligently, quickly becomes out of date very fast. It doesn't stay consistent with what the current implementation is, or current solution is. And then what does it do? It actually becomes more of a problem than a solution, because it's misleading. It quickly becomes misleading. So I think communication through documentation, through our code, through other things that I'll get into in just a moment. And finally, I think we need verification. You know, we set out to do something. How do we determine that we actually did it? What can we use? What tools do we have to verify that we did what we said we were going to do or what we attempted to do? So we need these things in place. Now, I'm going to bounce around a lot because these things are so interrelated. I think they're interdependent. They're kind of a spider web. And that's really the thing that I struggled with most on trying to put together this presentation, was how do I logically arrange these pieces in a sequential order, and I couldn't really come up with that. So please bear with me. Basically, we talked about discovery. Discovery is iterative development will help us in our discovery process, because if we do iterations, we can go back, take what we've learned, and apply it. The other advantage to iterative development is also in our verification. If we try to take a snapshot of our system and capture everything up front, then we build it, then we test it, we push off discovering errors in our system to the very end. Errors are the cheapest when they're caught early. The earlier you can catch a mistake, the easier it is to fix it. If we put off all of our error handling to all of our testing to the very end, and we only find our mistakes at the very end, then they can become much more costly to fix. Because what you wrote 10 minutes ago is a lot easier to fix than what you wrote 6 months ago. That's one of the best advantages to this iterative development, as well as the allowing for discovery process. Another thing is design principles. And when I talk about design principles, I'm talking about things like single responsibility principle, open-close principle, Liskov substitution principle, dependency inversion principle. Okay? These principles are really tools or guidelines for us as developers to use to help guide us as we're writing software, to guide us in a way to build software that is ultimately going to